And you're going to give me a sign when we officially are ready. All right, perfect. So, my name is Christian Teuschel. I'm from the RIPENCC, and I am as excited about this tutorial presentation as you, because I am a bit of a replacement. I'm a replacement Jasper. Jasper Den Hertog, a colleague of mine, he created the slides and the presentation. And unfortunately, he couldn't make it to Chiang Mai, but I'm here right now, so I'm the physical representation of him. But he's joining us remotely. Jasper, say hello, live from Amsterdam. Maybe give him a little bit of applause because it's 6 o'clock in the morning. Yeah, you see, we appreciate you getting up so early. The topic is Atlas of the Internet. And that has basically two connotations. First of all, RIPEatlas. You know about that. We will also explain a bit about RIPEatlas in the beginning. And the other part is Atlas in the sense of a map of the world, because we are dealing with maps. And that brings me to the, goal and purpose of this presentation. We will learn about geospatial data, and I mean, this is a very generic topic in a way. You can use that for any time you have to deal with geographical information. But the interesting part is that we will combine that with RIPEatlas data. And the goal is that you will be able to create insights on the network with a geographical context. Because you know the internet is topological, but we all live in a real world which is geographical, which is usually sometimes a bit of a contradiction. So maps, and we are going to create a map, you are going to create a map, will help you better understand what's going on the internet with relation to geographical information. For the requirements, so we assume that you have at least worked with Atlas before. Please be honest right now. If I'm going to ask you if you have worked with Atlas, then we simply know where we can, spend a bit more time on explaining the basics or moving through that a little bit quicker. And my colleague Leah, also from the RIPENCC, will assist you and help you with the logistics of this presentation and the tutorial. So I would like to see some hands. Raise them if you have at least worked with Atlas once. Ooh, nice. That's very interesting. Okay, cool. Okay, while I'm giving you introduction on the basics of Atlas, and I try to make it a little bit longer and trying to cover everything, I want to explain you that, well, in a nutshell, to work with Atlas, you need to have a SSO account, so a single sign-on account with the RIPENCC. It's very easy to do. So you're going to go to access.ripe.net, and you create a login and a password, and then you're ready to go. And then later, for Atlas itself, we're going to give you some credits, and if I'm not mistaken, that's 5,000 credits? 50,000? 500,000. 500,000 Atlas credits. I mean, that should already be worth it to create an account and get that credit. So you will get that credit by using the voucher code GEO48, right? GEO and then APNIC48. So while I'm talking, please log in on access.ripe.net, create the account. It makes just more sense if you do it right now, because Otherwise, the last parts of the presentation of the tutorial don't really make sense. If someone has any problems with doing that, then please raise your hand. Then I think Leah can jump to you and help you set it up correctly. Okay, then let's start with the Atlas. I mean, right now we don't call it refresh anymore, but the basics. I can tell you that Atlas was created 2010. So we started creating that, and the vision was to create a measurement platform for active internet measurements. And well, I have basically two hats. So one hat is, at the same time, I was busy creating RIPEstat. So you probably heard about that already. That's the open data platform of the RIPE-NCC, which simply you get access to a lot of internet datasets for data-driven decision-making. Atlas is a platform to create measurements. In the audience, who of you is working with data? Okay, interesting. All right, so then I think it would be interesting or good to know that whenever we are talking about the internet, there are three different categories of data. If you understand these data sets, then you can basically solve all the issues that you will encounter in your job as in running a network, access, content provider, that I think doesn't matter. The problem usually is that the data sets are not there. So, I mean, theoretically, we would know what would give you the answer, but the data is not there. These three data sets start with registry data, right? Registry data is, for example, all the RAR data. That is administrative data. It's usually done by humans, right? Someone goes there, types in, for example, the network, the organization, and other people fetch this information to use it. The second layer is passive measurement data. Passive measurement data, as the name implies, is something that you're gonna collect by not actively doing something. And a very good example is a log file, right? A log file from a web server is worth 1 million, right? If you know how to extract this information. You see the IP addresses, you're gonna see the clients, and with this information you can already give a lot of data and insights, for example, to the marketing department of your company. The example that we usually refer to in the internet space is routing data, so BGP data. The RIPE-NCC is maintaining a big passive measurement data related with RIS data, with BGP data, that's called RIS, so the Routing Information Service. And that is not part of the tutorial right now, but I just wanted to include it as to complete that. And an example of the third layer, which is active measurement data, and active measurement data is something that you actively have to trigger something to get the measurement results. And an example of that is RIPEstat. So, in a nutshell, we basically have the definition for RIPEstat. It is a distributed measurement platform that aims to measure connectivity. And what that means, we're gonna see in the next slides. So the different types that we have with active measurement data is, of course, a lot, right? What we focused on is connectivity, and that translates to the measurement types that we have here. So this distributed network of probes that we have all over the world, they support measurement types like ping measurement, traceroute, DNS, SSL and TLS measurements, and to a limited extent also HTTP measurements. To a limited extent, I'm saying because it is not possible to run HTTP measurements completely unlimited, because yeah, I think that would lead that would take a little bit too much time, but because it's being hosted by volunteers, and these probes can be hosted at locations with maybe restrictions on what you can do on the internet, for example, in the Middle East. And if you would allow measurements, for example, to a porn site, then we would, the host would have some problems. So we have some kind of restrictions on that. I think it's not necessary to say, but all the data that we're going to collect is publicly available. I mean, we stick to the community idea, right? Because we depend on volunteers to host this measurement, to host these probes. And Leah will later on talk a little bit about community, but what we should know about the measurement in itself. The system supports two types of measurements. If you're going to receive a probe, and I was just wondering, do we have a probe to show? That would be awesome. So, here is one example of the latest version of probes. I'm going to talk about the history of probes a little bit later. But the system in general separates two measurements, or knows two measurements. One are built-in measurements. So that means that as soon as you're going to connect a probe, they're going to run a certain program. For example, measuring certain endpoints. Every probe will, for example, run measurements towards one of the root DNS servers and targets that basically we define to get more insights on the state of the internet. But additionally, and this is the huge benefit of Atlas, is that you can also create user-defined measurements. So you can facilitate this network of probes to run your own measurements. And that could be your web server, that could be everything that we are not currently covering with the built-in measurements or by other people. But I'm going to get to that also a bit later. So here we are. We have, again, two different types of nodes in this network. One is these smaller scale probes that we usually distribute to users at home. And this is to extend the number of probes purely. And they run certain measurements, and then we also have some more powerful probes. We call them anchors. And the difference to the small ones is that they are more powerful. They can run more measurements. Other than that, the software is usually the same. So it is simply more powerful. So you could think of Anchor is a small probe on steroids. There's also one other difference. Since we have these small probes behind CPEs at end customers, we are very careful not to overload the network. So you can't actively select a certain probe as a target, right? But with these anchors, you can. So if you want to specifically measure a certain endpoint, then by having more anchors, you will also have more targets available. And I think that's also the idea. So we want to distribute anchors in data centers to attract local measurements. So that's also a benefit for the people that are hosting these probes. And talking a little bit about numbers, so we have more than 10,000 of the smaller probes, and I think recently we reached 500 anchors. I think that was just 2 days ago, right? Yes. If you're interested to host either one of the small probes or one of the anchors, then please talk with Leah. She will also set you up with all the information that you need for that. Yeah, maybe I should also quickly talk about the versioning of the probes. So from the small probes, we are with this one at version 4. At the moment, we are provisioning a new batch of probes so that we can distribute it. So they are not completely and fully available right now, right? So we are in the process of distributing new ones, right? But you might see probes that we have already distributed. They look a little bit different. Unfortunately, we don't have a picture of that. The first two versions of probes were highly customized devices where we, I think, produced only 3,000, right? Yeah, something like that. Then we moved to off-the-shelf product. It was a TP-Link 3095. I'm not sure about that exactly, about the number. But that significantly reduced the costs and we could produce in higher numbers. But they had one downside. They had a USB stick attached to it to buffer the measurements. And this USB stick sometimes failed. Poor quality. And to improve the resiliency of the measurement devices, we switched right now to these ones. And as I remember correctly, that's a banana Pi. NanoPi, a NanoPi, exactly. Thank you, thank you. Yeah. If you're interested in the infrastructure, let's talk a bit about this schema. On the right side, so we talked about the anchors and the probes. These are the data producers, right? So they run all these measurements, they buffer the measurement results. And then they're gonna get it to our infrastructure. Well, for the sake of time, I'm not going too much into details, but we have different APIs that you can get this data. One is the web interface, and today you will see the web interface. The other one will be the API, so it's a REST API that we have there. We also have a command line interface, a command line client interface, and then we also have streaming so that you get real-time data. And yeah, I guess if you're gonna have questions during the presentation, then please raise your hand and shout them at me. Here, you're gonna see the distribution of probes with hexagons. The size of the hexagons is defining the number of probes, and well, you do see that we have a bit of a bias in there, right? Most of the probes are in Europe, then in the US, East and West Coast. We also have, with the help of APNIC, we have a lot of probes in the Asian Pacific area. But there are still a lot of networks that are uncovered, and we would, of course, be interested to have them covered. So, if you go, for example, to the Atlas webpage, and you're going to look at this map, and it happens that you're in a network that is not yet covered, then we would be very interested to get in contact with you, and you becoming a probe host. Yeah, so we have a couple of most popular features. We do that very quickly. So streaming for real-time data, this is of course a very interesting feature. And then we have also something like a status check. The status check, so you're gonna create a measurement towards an endpoint, and it will basically take the history into account and will notify you if there are significant changes in the performance of the measurements that you created. For example, ping measurements, the round trip time. Yeah, I mean, I think this is very interesting for monitoring, but we are not going into the details about that. We're talking right now about what you can get out of RIPEstat as a visitor. As a visitor is basically defined as someone who is not hosting a probe and collecting measurements or creating measurements. And there we have actually some very interesting results. I mean, they are more focused on the global operation of the internet. We have a lot of maps there. You will later on create your own maps, but these are some examples of what we can do with the measurement data that we're going to collect in this entire system. I mean, the benefit of this network is that we have a lot of probes, so we're going to collect a lot of insights about the status of the internet. So what do we see here? Here we're gonna have the different results of ping measurements towards broute. I mean, broute is one of the root DNS servers, as you all know, and it's APNIC48. And according to that, you would see, no, hold on, is broute APNIC48? Jasper?
I think so.
Yes, okay, thank you.
Yes.
And that's being reflected in the, well, that's of course being reflected in the latency of the measurements towards those from the probes. You would assume that the ones that are closer to one of the endpoints of broute will have a lower latency. And this is, by the way, also a very interesting tool to help operators of, for example, root DNS servers to assess where they should put, where they should provision new nodes. Because if you see an area with a lot of, does that laser pointer work? Yeah. If you're gonna see areas in which you have a very high latency, then it would make sense to put another node in there. Then, yeah, we have general information like, well, this is, by the way, coming from RIPEstat. Is one of the widgets where you can see how many probes we're going to have in Thailand. At the moment, we have 13 connected, 45 abandoned, and 6 disconnected. And I think as a reminder, what you're going to see here is the historical development. And that is a little bit worrying, right? Because the blue one is the one of the abandoned probes. And worrying in the sense of, so the black line is the connected ones. The connected ones is going down. And if they are not connected, then of course they can't collect valuable measurement data. And the blue one is the one that are abandoned. And the definition of abandoned is that they were once connected, but then haven't been connected for 3 months. And for the ones that are hosting a probe, I think this should be a reminder, please check your probe. Not only if it's connected, but it could also be that it has a USB issue, right? You'll find more details on the Atlas pages, how to check that. But since we got way more people than we had in the beginning, I would like to restate my question. How many of you have worked with Atlas before? Okay, from the percentage-wise, I think, I guess it went down a little bit because we have more people, but okay, that's good. I would invite the people that worked with Atlas to come in the front to take actively part in the programming part a little bit later on. Yes, exactly. So for the people that haven't worked with Atlas yet, we have a very, very low requirement for doing this tutorial, and that is to create an account with the RIPE-NCC. So we need a SSO account, so a single sign-on account, and do I have to go? It's on the next one, right? The information about the login. I will see. If it doesn't come up in the next slides, I really have to go back to the beginning of the slides. Oh, I just heard it is on the chat of Zoom, how you would have to connect. I mean, it is a very easy URL. It's access.ripe.net, right? I can repeat it, access.ripe.net. Just log in with your email address, create a password, and then to work with the tutorial and to create your own measurements, we give you 500,000 Atlas credits so that you can spend on creating measurements. So for that high amount, I think it should be totally worth to go through the effort of creating yet another account on the internet. All right, here what we're going to see is the probes per country. No, forget about the scale, just focus on the colors. Blue one is good, dark blue is very good, yellow is less good. So if it happens that you are coming from countries that are yellow on this map, then again, please contact us. We would like to add more probes in these countries. Then we're going to get to the next part, which is looking up existing probes, public probes. And assuming that you already created an account, it's very easy to get there. So if you're going to go to atlas.ripe.net/probes, then you will get an overview of all the publicly accessible probes. And I would like you to follow with the slides right now. So that would require that you either use your laptop or your mobile phone. But I see that still some people are just checking Twitter or Facebook. So let's do it the way that for everyone who wants to seriously participate in the tutorial, and if we are going too fast, then please raise your hand, and then we're going to slow it down a little bit. And assume that the people in the back are, they just want to follow the slides, right? Is that correct? Okay, good. So, if you're going to select an arbitrary probe, then you get already a lot of insights about the probe itself. So, for example, you're going to get the connect time, you're going to get the traffic that it's producing. As a probe owner, you can also limit the traffic that's ongoing. That's simply to protect your own network. Then, what we also do is, we do tagging. So you can tag your own probe and in that way provide more information about the probe. For example, if it's in your home network or if it's at your company. And we do also system tagging, which gives you more insights based on the data that we're going to collect. So it could, for example, be that we're going to flag a probe as a DNS not working or that IPv6 is not working. That will help you later when you create measurements to filter on what you really want. Because, I mean, some people might want to restrict the measurements to IPv4 or IPv6 only. And let me just check on time. How are we with time? Because I should not spend half an hour already. Oh my God, I'm simply talking too much. For all the probes, we also have graphs that show you the ping results. So you can easily analyze the historical development of the probe that you're looking at. And for example, if you're going to run it at home, you could get into argument with your internet service provider, and if they're going to say like, no, everything is fine, then you could theoretically refer to these measurements to show that not everything is fine or everything is fine, and you just want to have that confirmed. This is important because we will use it later on, talking about how to get to the raw data of the measurements. Because before I only showed you maps that's based on the data, but if you're interested in the raw data, we have these APIs. So atlas.ripe.net/API/version2 probes. You can also get the information that you see on the web page. So with the visualization, you can get that via the API. So that's for more the power users if you want to create your own apps, own visualizations, or maps, as we do it a little bit later. Okay, as I said, there are already a lot of measurements in there, and there's usually a benefit not to reinvent the wheel, right? If there are already measurements for a certain case, then it is beneficial if you just use these measurements instead of creating your own in a way. And right now we simply look at that a little bit. So a slightly different URL, it's atlas.ripe.net/measurements. And then you're gonna have access via this page to all the publicly available measurements. Again, this basically reflects what we said in the beginning. You can filter on ping, traceroute, DNS, HTTP, SSL, and so on. Measurements, Wi-Fi measurements, by the way, they are not accessible anymore, so we might have to update that. On this ping tab, you get already a lot of information, for example, the target or descriptions. Then you can have the different measurements of running a measurement as a one-off. That means that the system creates a measurement and collects the results in one go, but then stops. Or you're going to have ongoing measurements, right? That they are spreading a time period. And then you have an interval that you set, but we're going to get to that a little bit later. So also a bit more visualizations. I think I'm going to go through that a little bit quicker. So we have visualizations related to the type of ping measurements. Well, maybe one visualization that should be highlighted is latency mon, where you're going to see the ping results similar to the ping graphs that I showed you in the beginning, but this allows you to compare different measurements. Then we have tracemon. This is a visualization for traceroutes, which is in itself a very tricky business. The tracemon measurement shows you network topology, latency, and node information. IPmap. This is something we, I think, cover a little bit later on, so I'm not going to spend too much time on that. Yeah. DNS measurement, similar. Here is this is important. So if you want to get to a certain measurement, so imagine you went to this overview tab, you selected an interesting measurement, then you're going to click on the results link, which gives you the options to download the measurements, and you can restrict, for example, for ongoing measurements that you simply just want to have a certain time period. On GitHub, we have libraries that will help you to parse the results, for example, for Python. But yeah, again, not going too much into details. Quickly look at a result. Interesting here is the destination address and the name of it. Then it's also important that you know where the measurement ID is, because the measurement ID is usually important because we refer to these. If you want to share measurement results, then this can be easily done with a measurement IDs. And here you're going to see an example of ping measurement, and this is how the payload looks like. You can also access the measurement results via RIPEstat. So in RIPEstat, you're going to type in a resource, and then we're going to show you in a widget what measurements are related to that, either source or destination. Yeah, measurement ID is important. If you want to find or share a specific measurement ID, remember that, and then just append it at the end of atlas.ripe.net measurements and then the ID. As I said before, if you are looking actively for certain results, then first check if we have existing measurements, because that will save you credits and also remove a little bit of the strain on the system. Now we're going to get a bit more to the interactive part. We're going to create a measurement, right? I think you were all already excited to create a measurement, right? And for me to skip the basics. And that's what we're gonna do right now. So the benefits of your own measurements is, of course, that you can customize it to what you want, right? As I said before, one-off measurements, ongoing measurements, you can define the type of the measurements or the interval. And here again, the very important page, before we're gonna go into the tutorial part, is you need to have a RIPE access account. Right now, I would like to see some hands, because probably everyone is raising the hand right now. Who has a RIPE NCC access account? Perfect. That's what I wanted to hear. You just made one, at least, right? Yeah, for the people in the back, please take a screenshot of that and then do it at your own pace. It would be access.ripe.net or ripe.net/register. And the very important part, right? I mean, this is about serious money, is the Atlas credits. You get 500,000 of Atlas credits by using this voucher code, geo48, right? Very creative. Geo for map, 48 for APNIC. Okay, then we're gonna log in to access.ripe.net. And then we're gonna, no, hold on. We're gonna go to atlas.ripe.net and then we're gonna log in. And after you successfully logged in, you will be able to create a measurement. I think you first have to redeem the voucher, right? Hold on. Leah is right now providing this very crucial information.
Sorry. So you go to RIPE Atlas, you go to My Atlas on the tab on the right, on the left-hand side, and then there's credits under there. And on one of the tab, there's a redeem voucher, and you can use the voucher GEO48.
Thank you very much. Is it on the left side from my point of view or for the audience point of view? Ah, okay, of course. So, good, then credit system. So why do we have a credit system? Yeah, perfect. So who is already half a millionaire in this room? Nice. Well, Jeff, I think you're more than half a millionaire, right? Related with Atlas credits. Okay, cool. Yeah? So we simply have this credit system to keep the system fair, right? We need to find a way to you know, reward people that are hosting these probes and people that are, I would not say exploit, but use this system and create measurements, right? And that's why we came up with this credit system. If you're going to host a probe, you're going to get credits on a daily basis. Of course, for a smaller, is there a competition going on? Oh, seriously, 311 million credits. Jeff, what do you have? So, okay, so, all right, so we need to, tonight at the social, we know who to stick to, right? All right. Yes. How many do you have? All right, okay. I would like to know the exchange rate. Yeah. Or is it like Bitcoins? It's nice to have one, but if you want to convert it into fiat money, then you lose a lot. Okay. So the reason why we have this credit system is simply to keep it fair. Some measurements are more expensive, of course, and some measurements are less expensive. We do, by the way, have, when you're going to create a measurement, we're going to have a graph that gives you an estimate of how many credits you would spend if you're going to run it as a one-off or ongoing. Then, yeah. We should next time put a screenshot of a really high number, right? Because we can, right? So, exactly. You can also transfer the credits. It's probably like, you know, air miles, right? Yeah, we should not spend too much time on that. Scheduling a measurement with the web interface, also very easy. You're gonna go there. Then if you're gonna click on the button create measurement, then you will see this user interface. You're gonna define what kind of measurement type you want to have, and then you're gonna set the properties that's depending on the measurement type. We're not gonna go into details about that because we are doing bad on time, right? Bad on time, okay. Here you can select the probes. That's a very important thing, and that's the benefit of this distributed network, right? Because, I mean, theoretically, you could run all these measurements from your laptop, right? But if you want to have remote measurements, then this network shows its strengths, right? And here you would define if it's a one-off measurement or from which time period, so when do you want to start the measurement and when you want to end it. Scheduling a measurement, yeah, we skipped that. Here we have a tool that let you geographically select probes. You can put in filters like prefix, ASN, and then you would see it on a map, how that would translate to, right? I think that's also quite straightforward. We quickly run through the use cases, and then I think we come to the well part, yeah? How we time again? Okay, half of it. That's fine. So we have a couple of use cases for Atlas, of course, that made it to a publication. One of the more interesting ones is, of course, the attack on Dyn with the Mirai botnet and cloud connectivity. Yeah, let's look at this one. IXP Country Jedi. IXP Country Jedi is a tool that has been enabled through Atlas, and let me quickly explain that. What we wanted to do with that is, so we know what probes are within a country, right? And what happens if we orchestrate the probes to send a traceroute to each other, right? Then we're gonna create a mesh measurement. And then you would assume that if the probes are in the same country, that it should stay in the country, the traffic. I mean, the path that is being taken to send data from one node within the country to another node in the country. And to make that more visual and easier to understand, you need another data set for that. And that's simply a GeoIP dataset. GeoIP dataset, every one of you knows, right? It's a simple mapping between an IP address and the location, respectively the ASN, right? You can derive that from the IP addresses. Sounds simple, is not. It's so many things can go wrong, and they do go wrong with GeoIP datasets, and Jeff can, I think, refrain with that, right? So what we're gonna do is we're gonna collect these trace routes that we create when we're gonna run measurements from one node to another in the country, and then we geolocate it and put it on a map. And then you're gonna see something like this or this. That was done for Sweden. Yeah, I think let's make that also very quick. What you see is if local traffic leaves the country, that is bad for various reasons. First of all, someone has to pay for the traffic if you're gonna send it somewhere else, right? It's more expensive, less efficient, and also in the sense of routing security or national security. I mean, what if it's sensitive data that you want to keep in the country and your neighbor is not as friendly as, for example, Austria? Then you would rather not have the data pass your borders, because if the data passes your borders, you're regulations and rules on data protection or whatever are out of the window. So that's a very interesting use case to visualize that. And that was enabled by Atlas with of course, a good GRP dataset. Then that was related with the DDoS attack, and yeah, you simply could see that in the latency mon, that a lot of probes from the same network simply suffered from the same impact. Yeah. This is a power outage that we had once in Amsterdam. Power outages are not that often or regular than in the US, but sometimes it happens. And what you could see is that the probes, if they lose the connection to the home network, then we see that, of course, right? We can monitor that, and we have events on that. So a connect event and a disconnect event. If suddenly huge parts of a certain network go down, then it's a very strong indicator that something is wrong there. And in this case, it was a certain network provider that was affected by the power outage. And in this sense, you could see that. Then I think we're gonna come to the community, which of course is very, very important. And I would ask Leah to. Yes, absolutely, absolutely. So if you're okay with that, and I think you don't have really a choice, we're gonna do that at the end. To start with the tutorial. Jasper, are you with me?
I am.
Perfect. So then we're gonna skip the next 4 slides, and we're gonna move in medias res. Geodatasets with Atlas. Jasper, you just sign me when I should go to the next slide, okay?
Yeah, I will. So geodatasets. First, I want to talk a bit about what geospatial datasets really are. Might sound really simple. If you give me the next slide. Yeah, so normally we would say like these are encoded points, lines, and areas on the surface of the Earth. That's not entirely true. There are also different type of geospatial data sets that are derived from satellite images, which are basically raster images, but it's completely outside of the scope of what we're trying to do here. So normally we would have to have a method to, first of all, describe the surface of the Earth correctly, and then a method and a data format to encode points, lines, and areas. Next slide. So what you really need to describe the surface of the Earth sounds pretty easy, but it's in reality one of the hardest mathematical problems and measurement problems there are. First of all, you need to have a coordinate system. You have to have a way in what units you want to describe the surface of a curved body. That would be on the left side. So that's not only whether you want to describe it in a mesh as a point on a mesh or an angle with a distance. But it also involves the thing in the middle. You have to have an idealized shape of the Earth because a normal ball-like object will not do. So it's probably you want an ellipsoid. Most geographical projections use a ellipsoid. And then the third thing is the most difficult thing. You need to have a way to account for the differences between your idealized object, the ellipsoid, and the real surface of the Earth. And it was only until the late 19th century that Gauss, the guy from statistics, the Gauss curve, thought of a mathematical way to describe this discrepancy between the idealized ellipsoid and the real Earth, which is called the geoid. It's a fascinating thing in itself. He made both engineered a solution to measure the gravitational field of the Earth and to map that, and a way to describe this mathematically. If you take these three things, this results in what is called a geographical datum, or in computer terms, a spatial reference system. And there are like hundreds of reference systems, most of which describe parts of the Earth very well, but do not describe the whole Earth well, not even correctly, but not even in a way close to correct. That was alleviated by the WGS, the World Geographic System, which we invented before the global positioning system was invented, but it was perfected to basically accommodate GPS. And the most current version is from 1984, so it's called WGS 84. Next slide. And then this is nothing to do with the, well, it is something to do, but it's nothing to do with the geospatial data per se, but it's the actual map projection. A lot of people confuse this, but a map projection is just the way you're going to go from a spatial reference system that describes points on the Earth to a flat projection. So this is completely separate from the reference system itself. It's just a way in which you want to stuff that fits roughly on a globe, how you want to present that on a flat surface, paper or a screen. So there are many projections. The worst of all, I've not shown you here, but you saw it in an early slide, is the Mercator system. Never use that for representing the complete Earth, unless you want to navigate the seas from Europe. There are way better projections, and hopefully I'll be able to show you some. Next slide. Fortunately for us, there is a way to use the WGS datum with a very easy data format called GeoJSON. GeoJSON by default uses WGS 84, and of course it uses JSON. Next slide. Some of the benefits is like all JSON formats, it's human readable. It's an IETF standard, although a bit sparse one, but yeah, hopefully there's going to be a successor to that. There's many libraries who know how to convert it to any other proprietary or open source geospatial format, most notably Esri's shape format and the newish GeoPackage format. There are support in many software packages. There's an open source client, very good open source client called QGIS, which supports it. There is a Postgres database extension called PostGIS that has a very good support for it. It's the de facto standard in browser environments due to libraries like Leaflet and OpenLayers. And yeah, WGS is the default SRS for mapping stuff to the world because of GPS and because of its relative accuracy. Next slide.
Just a moment, I just get me another water, right? Yeah, hold on.
Yeah.
Multitasking.
Yeah. And we sport it in Atlas in various places. It's somewhat underdocumented, but it's also used in IPMap. But if you go to any API page and you click on the green button, that opens up a drop down with all the available formats. And for example, in the probes archive, you see that you can output this GeoJSON. Next slide. So the GeoJSON format looks something like this. Hey, somebody changed my slide. What happened? Well,
I think it's PowerPoint. It was not me.
So these circles, you should translate these circles somewhat downwards. So there's some boilerplate that describes what's in the file itself. 90% of the time you see type feature collection. A feature is a point, line, or area on the face of the earth. Then you see an array called features inside that inside JSON object. So type feature, again, most of the time you see type feature. You can also have other metadata, special metadata stuff. But like 99% of the time there will be feature. Then a field called geometry with a sub-object that describes what kind of type. So that would be point, a line, or some kind of area subdivides in different types. So not that interesting right now. Then the coordinates. So for a point, there will be 2 coordinates, and those are in WGS84. Unless somebody specified in the top of the file another datum. Then the properties field hosts all the metadata that you want to attach to this point. So for a RIPEatlas probe, that would be the publicly seen IP addresses, the ASN, country code, and other stuff. Next slide. So some mainly in our line of business, the most used geospatial datasets are probably the GeoIP datasets, and those are simply datasets that try to resolve IP addresses to a location on Earth. Most of the time that would be a point. There are many commercial offerings for this. MaxMind jumps to mind. That's probably the most popular one, mainly, I guess, because they have this GeoLite 2 free dataset that's easy to use and easy to get hold of. But there are others. There's NetAcuity, there's IP.net. Yeah. And then there is, next slide, please. The RIPE NCC's IP map. This is a product that we've been developing for a year and a half now, I guess. That tries to leverage the RIPEatlas infrastructure to figure out whether IP addresses are in the direct vicinity of probes. And if so, we try to sort of figure out where they exactly are. So it's a data set that is has holes in it because of stuff that we cannot basically calculate because they're too far away from probes. But for the stuff that is in the vicinity of probes, it's the accuracy is relatively high. There have been papers published that on for country level accuracy, we are one of the best data sets around, and we're trying to get to city level better. And it has a crowdsourced part where you can actually, where anybody basically can contribute to this data set. Next slide. So it has an API. The easiest call is so you see of course the IP address, and then /best that would return only one location where we calculated that this would be based on both the probes. We call that the single radius engines. And crowdsourced engines, and we have a method to score the different engines. Next slide. You can also go into more detail on that API, but it's probably also outside of scope now. We have an interface also to IPMap embedded in Atlas for visualizing traceroutes. So every hop on a traceroute, we try to geolocate with IPMap and then put it on the map. So the more data we have in IPMap, the better this visualization will look. Next slide. Yeah, and then we have IPMap.RIPE.net, which is just a front end for the API right now. It's just the way you can look up one IP address and will give you, it will either start a active measurement if it doesn't know the IP address, will display the IP address if we already have it in our data set, or it will just simply say that it cannot geolocate it. Next slide. Okay, so now for the tutorial part. I'd like to use two
Jasper,
different online
sorry
tools
for
for
interrupting
visualizing
you.
stuff. One is
Jasper, just a moment. I just wanted to check with the audience where we are and quickly recap. So we learned that basics about Atlas, how to find probes, how to find measurements, how to create measurements. We discovered that Jeff is not the richest person related with Atlas credits in the room. By this, so with the tutorial, I think everyone should have a RIPE NCC access account that we can continue with that. If someone has problems with that, then I think right now is the right time to speak up. So I assume that the silence means that everyone is okay with that. Yeah? By the way, Jasper, you're on a houseboat, right?
Yeah. I'm on a houseboat,
yeah. Yeah, this is an original houseboat in Amsterdam. Should be noted, right? Look at the ceiling. Dutch people are very tall, but the ceilings are not very high.
Not on houseboats now.
No, not on houseboats, right? But they're very popular in the Netherlands. Okay, Jasper, I'm going to give back to you.
Yeah, so I had two more slides about the online tools that I wanted to use for this tutorial. So the one is geojson.io. It's on the right side. You can just copy paste a GeoJSON structure, and then I'll try to, if it can figure out if it's corrected GeoJSON, it will put it on the map. I've never tried this on areas, by the way, and only for points. I have no clue. But this is a very quick way. If you go to the probes API, for example, in Atlas, you specify format as GeoJSON, you can just output it directly into this online web application. Next slide. And the other one is Observable HQ, that used to be called blocks.org, I think. It's mainly a fancy front end for a library called d3.js, which allows to make you like lots of different predictions of the Earth and then project data on it. And it is also very good at transforming GeoJSON datasets. And it can also, with the help of some other library called Turf, to do geospatial calculations on datasets. And I also wanted to use that in the. I prepared a notebook. It's a bit like Jupyter notebooks, if you're familiar with that. So it's a live coding environment that you can intersperse with text and commands. You can sort of make a coding story.
So you all know Python notebooks, right? Jupyter notebooks? Yeah, it's a similar concept.
Yeah, it's a similar concept, but then based on a JavaScript environment. So probably you could also do this with Jupyter notebooks, but I'm not so familiar with mapping libraries in Python, basically. Okay, the next slide. Yeah, so now we're going to start the tutorial part, I guess. Next slide. Yeah, so I have concocted a very simple use case where we want to measure the Wikimedia CDN. Wikimedia CDN is, I think, a good use case because it's a CDN, it's a DNS-based CDN. So that means that if you take probes from all over the world, then probably you get and you start measurements towards dyna.wikimedia.org, which is the entry point for the CDN. You get back different IP addresses based on the location of the probe. Although that's to say that's the theory that should happen. So Atlas is in a good position to measure the efficiency of the geolocation and the routing of the Wikimedia CDN. Next slide. So here's what we're going to do. We're going to start a new traceroute measurement to dyna.wikimedia.org. As I said, that's the entry point for their CDN. Then the second step would be to select a set of probes. You can select probes of your own choice. Best is to not take more than around 10 because of the visualizations. If you take more 10s, your visualization will be slower and more cluttered. Then the third step would be to actually set the target to dyna.wikimedia. And then fourth is to go to the observable notebook that I prepared. I'll show you the URL later. And then you can, that has a measurement that I already created in it, but you can change it to reflect your own measurement ID. And then the fifth step, that would be the fifth step. And then you can fiddle around with that. And maybe there's also no time to show you how to work with GeoJSON IO and our probe here. Next slide. So this is what Christian already, again, this slide is a bit worse. But again, this is how to create a measurement. So if you all go to atlas.ripe.net and then /measurements, then there will, if you're logged in, make sure you're logged in, and then you'll see a green button on the right side that says create new measurement. And you should start a traceroute. Then go to the probe section. And in step 3, we'll get to it, but I'll repeat this. Do not forget to say to check this is a one-off measurement. Otherwise, you'll create a measurement that goes on and on. Next slide. So that's where you fill in dyna.wikimedia.org. Do not forget to check resolve on probe. This is very important, by the way. This is, unfortunately, the default is to not resolve the hostname on the probe. So that means that the hostname would be resolved on our infrastructure in Amsterdam. So you get the IP address of the Wikimedia infrastructure in Amsterdam. And then if you select probes from Thailand or Australia, you'll see abysmal latencies because everything is going to Amsterdam. So instead of that, you would want to resolve the hostname on the probe so that the geolocation will be figured out correctly. Next slide, I guess. Am I going too fast for people or? Christian?
No, I think it's everyone is focusing on either email or the tutorial.
Okay.
I think it's fine.
Then the next step would be if you go to the thing that's called step 2 in the wizard, you can say I always forget what is this called. This is called let me see.
It would be here. So step 2, probe selection.
Yeah, no. Wait a second. I'm going. Yeah, and then
it's new set wizard.
Yeah, new set wizard, exactly. That's I always forget, new set wizard. And that will get you the map. And on the map, you can either select by, on the left-hand side, you see the rectangle and the circle. You can make rectangular or circular selections on the map directly. Or in the input box on the top side, you can specify an AS if you want to select from an AS. Then if you have selected probes on the right side, you'll see them appear and you can say, okay, do not forget to click okay, otherwise they will not be added. You can still edit the set later, by the way, on the underlying interface. Do not forget to click okay. And then in the underlying interface, you can still remove probes from the selection. Next slide.
So in this step, we're going to define the probes from which the measurements will run towards Wikipedia, right?
Yeah. Yeah. Okay, and then so in the sort of grayed out in the underlying interface, you'll see the probes that I've selected. So in this example, that's 5 probes. And you see still the remove buttons where you can also add new sets. You might also be able to add a set based on country code, or a set of probe IDs if you already prepared that. Again, do not forget to check that this is a one-off measurement button, otherwise your credits will be gone very fast. And then you can actually create the measurement. But if you do so, you get this screen. You get a pop-up that gives you a measurement ID back. You can click on that measurement ID. If you do, you will be taken to the measurement detail page, which has all the metadata of that page.
And the measurement detail page lets you also see the ongoing measurement results. So you slowly see up how the measurements are being collected. Yeah. This is very interesting.
I think that's on the, if you go to the next slide, I think that will show a measurement detail page. Yeah, exactly. So on the left-hand side, you're seeing a measurement. So if you go to the measurement detail page, you click latest, and probably you see something resembling the left-hand side, which is empty measurement results, because our infrastructure is still scheduling stuff and it's still working on measurement results that are pouring in. But if you refresh that page for a few times, then in the end you'll see something like the right-hand side of the screen, which shows you, if you see the green bars in, what is it, the third last columns, those indicate latency of the end result.
So who followed this step so far?
Destination.
Yeah. Yep.
Yeah. So if you go to the next slide.
No, hold on. We have a question. What was the target again? And I'm gonna go back. The target was
dyna.wikimedia.org.
Dyna?
It's also in the top.
Dyna?
On the top.
Wikimedia.org. Yes.
Yeah.
DYNA.
Yeah, it's on the top,
Wikimedia.org. Yes, but do you have that in that notebook as well?
Yeah, in a notebook there's...
all right, but we need to have the measurement before we're gonna continue, right? And... because of the resource. Oh, we might have an error.
An error?
You did the dyne.wikimedia?
Yeah.
And if you're going to click on the measurement ID? Yeah. All right, okay. So there seems, hold on. No, I mean, we just built an in to check who did it, right? So, who got an error? Who didn't even try? Okay. Jasper, in case there's an error, we might use an existing measurement, right? It's the best.
So the next step. So I prepared a already existing measurement for the node.
You have already an existing measurement, right? Wonderful.
Yeah.
So I mean, this step is only to show you how to create a measurement, but it is not 100% necessary that this measurement will be used for the tutorial. So we have already created a measurement that we can use. For the people that got an error, I would like to get back to you to identify what was the issue, but for the sake of time, we're gonna continue. Jasper, I'm gonna go to the slide that you ended with, and give it back to you. In the meanwhile, I just walk around to check how many people are participating, and you just talk to distract them, okay?
Now, if you can give me the next slide, the distraction will be even better. Yeah. So if you do have results, you can go to any other tab in the measurement detail page, like IP map. That will show you something like this, hopefully. You can go to Tracemon, which will show you a graph of the traceroutes. map will show you only the probes with the RTTs to the destination. Yeah, and latest result I already showed you.
Did your measurement succeed?
So something like this.
Yeah.
Nice.
They were not available.
Yeah, if you can go to the next slide.
The probes that are not available for the results, so that you don't want to have a lot. So if we're gonna go to latest results, yeah, the data is not there yet.
No, it's not there yet.
Yeah, it's still collecting. Oh, sorry, I was distracted.
Yeah, if you get the next slide,
Of
then.
course. So this is the URL that's very, very important, and I don't know what the S is doing there.
No, me neither.
I think it was
not on my. It is not on my original slide pack. So.
Huh. I think it was created by converting Keynote to PowerPoint.
Oh, okay.
It's a marketing strategy of Microsoft.
Oh, okay. So that's the URL.
So can everyone see that? Would it be possible that we're going to put it on the Zoom chat, that URL?
I can do that.
And the slides are online, so theoretically you have no excuse not to do it. Yeah, we have 15 minutes left. Jasper, we have 15 minutes left, so keep that in mind, because we also want to talk and hear from Leah about the community. All right. Okay.
Then
Leah is
let's
a little
move
bit
on.
shy, so.
If you move to the next slide. Yeah, so this is what an observable notebook looks like. It consists of pieces of code where you can load data or transform data, and then you can make visualizations with that, with D3. So on the top line, you'll see a API call reference. So it's atlas.ripenet/API/v2/measurements, and then the actual measurement ID. So what you're seeing here is the measurement that I prepared, and you can replace that number with your own ID. And then you can, if you see a arrow on the right hand side, you can push that and it will rerun all the code, and it will show your measurement. Next slide. I'll walk you through what I did for transformations. So each block has this vertical gray line next to it, and if you hover over it, you'll see the 3 dots for a drop-down menu. And if you click that, you can edit the block of code. Next slide. Oh, sorry, last slide. I only made one slide for this. Sorry. Can you go back to the firm? Yeah. So if you scroll through the notebook, you see that what I prepared here is I calculated the complete path length for all trace routes. So I first did a call to our measurement API to retrieve the measurement results. Then a call to our probes API to retrieve the locations of the probes. Then a call to IPMap that gets all the IP addresses of the intermediate hops and tries to geolocate them. So what you see here is all the green and reddish things are the probe locations. The green lines are the lines that are going towards dyna.wikimedia.org, although the instance that these probes are going to, they're all in Singapore. So the green line is the idealized path. You know, if for some reason, for spectacular reasons, there would be just a ideal path. It would be a straight line, of course, from the source to destination. And the bluish line that goes all over the place, that is the longest path that was in the all the traceroute results. This is a pretty interesting path. It goes from the east coast of Australia to the west coast of the US, goes down from the west coast to the US, goes to Europe, goes back again, goes to Singapore. So that's quite a path. And the color of the probes indicates the efficiency of the path and the round trip time. So, you know, the speed, if you will. So that's about it. If you manage to put in your own measurements, you can expand any code block and fiddle with it. You can, for example, on the right side here, you see the bit that sets the minimum RTT. It says now p dot velocity. You could change it into minus RTT, and then the color of the circles would indicate not the speed or the efficiency, but the minimal RTT. You could also do the same with the path length, for example. So that's about it.
Whoa, nice, nice. So actually, I had in mind that for the person who could do that with their own measurement, or at least, you know, render it on their own screen, we could give out a Dutch treat, which is called stroopwafels. It's way too much sugar.
Do you have them with you?
So the thing is, I kind of forgot it at my room.
Oh.
But
can collect it social or what?
All right. Okay. So we have kind of another token of appreciation if you really finish that. It's also from the Netherlands. Is peppermint Wilhelmina. It features one of the queens of the Netherlands, and so this will be given out today. No, I mean right now for the ones that manage. And I will, if I'm not intentionally forget again, the stroopwafels at my room, will bring it to the social event tonight. And for everyone that I remember here that finished this tutorial and will approach me at the social event, given that I did not forget the stroopwafels, will get the stroopwafels. Huh? That is, I mean, the probability that that will happen is quite high. So, could I see some hands who finished that? So I have 2, 3, yeah, okay, 4. You got it as well? Oh, an error. Yeah, you could use the measurement ID that we provided in the tutorial. Yeah. Well, on the other side, there's only one package of stroopwafels, so I mean, was there? Did you have a question? No. No, but you did it. Okay. Maybe the best is you're going to leave your business card with me for the ones that did, and then we do a lottery at the at the social event. Given that I don't forget them, right? Okay. Cool. Shall we move over to the questions? And then if we're gonna have time, we're gonna do the Atlas community. So, do we have any questions about this? Questions like, is there inflation with RIPEstat credits? I don't know. Probably not. Yes.
Well.
Desperate for questions.
Regarding the IXP country Jedi, yeah, do you maintain a list of the IP addresses used by the IXPs because you actually check whether it go through IXP?
Yes, we do indirectly. We use PeeringDB for that. But Jasper, you might correct me on that.
Yeah, we use PeeringDB, but we also have a corrected list that we have in IPMap as a separate engine. So that's an engine that hosts PeeringDB plus some more knowledge around IXPs. But in general, we try to match those up. So if we do see differences in IXP's lens that's not in PeeringDB, we try to motivate IXPs to correct that in PeeringDB.
Okay, so
PeeringDB should be fine.
As a data user, I would connect your question with, is this data somewhere available? As a list.
It's on IP. It's on the API of IPMap. Has a separate data call where you can specify to see the IXP engine only, and that would be there you could ask for IXP lens, but we do not provide it in a separate dump file, although we could do that. But again, we try to match this data set with PeeringDB. We try to be not too smart about it, because we really think there should be an incentive for IXPs to be correct in PeeringDB.
Yeah, PeeringDB should definitely be the authority over this data set. Yeah. But maybe it's an idea to add the URL to this data set, to the IXP engine in the Zoom chat.
Yeah, let me see if I can find it.
Yep, okay. And meanwhile, I think if there are other questions, we could move to that. I mean, you don't get strobe buffers for the questions, so that keeps the motivation low, I know. Next time I'm gonna take 2 packages of strobe buffers with me, one for the tutorial and one for questions. It's not fair, right? Because it's not the right way to assess effort, right? Okay, then I would say we quickly cover the community part. Let me check on time. We probably have 5 minutes left, which is 3 minutes left, which is ideal to end this tutorial with our beautiful Leah giving the information about the Atlas community. Leah, please come to the floor, and I will try to go back. Entertain them.
Singing? That's tonight, I think. So yeah, my name is Leah Estina. I'm from the RIPE-NCC. I'm just going to talk shortly about the RIPE Atlas community. And actually what's important that we are now in APNIC region is that we are working closely with APNIC, and right now there is this community trainer program where you can talk to the community trainers about the RIPE Atlas. You can ask them about the RIPE Atlas, and also you can get the RIPE Atlas from the community trainers. Jehu is here. He has some props with him, yes? And also Warren, right? Okay, so yeah, talk to Jehu or Warren, and you can get some props and information about the RIPE Atlas. So, as Christian mentioned earlier, the RIPE Atlas will not be there without the volunteers, right? So we need volunteers. We need more and more people to plug in the RIPE Atlas so that we have more diversity in the network that we covers around the world, especially here in Asia Pacific and also other parts of the world. We still need some coverage. So, and we have the organization who hosts the RIPE Atlas anchors that was already mentioned. If you can help us with installing RIPE Atlas anchors. Right now we have the virtual anchors, so we skip the logistic issues that we had with sending the probes in many countries that have custom issues. With the RIPE Atlas virtual anchors, we solve that problem, right? And it has the same requirements. You can just go to ripeatlas.net and apply there. And further, since 2014, the RIPE-NCC members is supporting the RIPE Atlas in the infrastructure and the maintenance, and for the expansion of the RIPE Atlas so that we can still give out the RIPE Atlas free of charge to everyone, we are using the sponsor funds. So if you are interested and if you like the project and would like to do something good for the good of the internet, yeah, let us know. We could use some more sponsors. Yes, so we can't do this alone. We need the support of the entire community. That's why we work with a program that we call RIPE Atlas Ambassador programs. So the RIPE Atlas Ambassadors they are people around the world who believe in the project and they know how to use the platform, and they use it for their day-to-day lives, and they also give presentation about the RIPE Atlas, and also they distribute the RIPE Atlas for us. And if you would like to become an ambassador, you can do that. You can just let us know. The benefit of being RIPE Atlas ambassador is that you get some credits, an incentive of the credits that the probes that you distributed. So, if you are developers, you can help us by contributing in making something of your own and share it with the community. We have many people that created something either during hackathon or just on their own and make some systems based on the RIPE Atlas data. Yeah, if you're network operators, you can just use the platform to monitor and troubleshoot your network. And the other thing which is also important is that we would like to encourage you and stimulate you to, if you are a researcher or students who, if you need a topic in your research, you can use the RIPE Atlas as a tool to do your research. Yeah. And yeah, the last thing, it's if you would like to host the RIPE Atlas probes, you can just go to ripeatlas.net and apply to host the probe, and you will be sent a probe. Right now, we don't have any stock. The next stop will be available approximately in November. And yeah, what's important is when you get your probes to plug it in, because if it's only laying in your drawer, it will not be useful for anyone. Thank you. If anyone has any question about RIPE Atlas Ambassador Program or something else. Yes? The virtual probes? It's actually on the website. If you go to host an anchor, yes, so you can, so the RIPE Atlas anchor is just the same as the RIPE Atlas, the virtual one is just the same as the hardware one, right? The only thing is that you can just install it in your own machine. Is this enough information for you? Oh, so you need to apply first, and then the process will start after that. You will be sent image that you can install in your. You can apply for both. So this one, yeah. Is there any other question? Okay.
So we got 2 more questions, maybe 3 even. Okay. I listen and then I proxy it, okay? Yeah.
Me, Susu Win from the Myanmar Computer University. I'm interested in the research, in the paper and research. I'm former in the remote sensing and GNS. So currently my student do the urban detection in remote sensing and GNS. Whereas RIPE Atlas, I can do the paper and research for the continue my further studies. Thank you.
Yes, so we have even programs for academia. The best is just to send us a mail if you want to do a big scale measurement, and then we're gonna provide you with credits, more than we gave out for the voucher, but you know. And you simply describe the project so that we have kind of a reference and that we can also consult how to run the measurements, because sometimes if the measurement creation is not done properly, then it could create some problems in a way. Okay, then we had another question from this corner. You had? No?
Just checking the result.
Oh, the checking.
Measurement results.
All right. Okay.
It's not working, so I asked you.
Oh, it's not working. I
No,
see.
not.
Now it's working. All right. Some problems solve themselves by themselves. Any more questions? Since I'm already here in the back, I'm so lazy. I can tell you. No? Then I think we can conclude it. Jasper, thank you very much for getting up so early.
You're
and
welcome.
yeah, being part of this tutorial. I enjoyed it very much. I enjoyed it very much. Now,
Thank you
I
for
mean, right now you
presenting.
could say I enjoyed it also very much, but it's fine. Okay, good. Thank you, Leah. Thank you to the audience, and I guess we're gonna see each other around. Definitely a social event, and I will promise to bring the stroopwafels. Okay? Thank you very much. Goodbye.